Okay. We can start this networking session. I thank you very much for your presence. I see that it is very, it's full, this room. I regret with the audience outside the room. Okay, my name is Giovanni Schembra. And I organized with a colleague of mine from the University of Catania, Giacomo Morabito, this networking session. The title of this session is Stop the War of IoT Stacks for Big Data and Management and Orchestration. This session is partially supported by a European project input that regards in-network programmability. For example, the website of this project hosts the official website of this session. IoT is very important today. If you make this question to the generic audience, which is the next big thing in communications, the answer is that we have 50 billion of IoT devices we will have within 2020, and if you visit Google Trend, you can observe that we are in a very deep trend that is increasing very strongly. If you make the question to the scientific community, you can realize that the most downloaded paper in IEEE Explorer regards IoT, and the most downloaded paper in computer networks regards IoT again. The industry is, the answer by the industry is the same. We have many companies that are working on IoT. The problem is that we have a multitude of standards. You can see a short list here. But the existence of an heterogeneity of standards, of equipments is not new. For example, if you want to print or to scan a document with your laptop or your PC, you use different solutions, but the real solution is that we have an operating system that makes uniform the heterogeneous devices. So the target of this session is please stop the war of IoT stacks. We are pacifists in this context, and we are now to stop this war. We have here four teams, four different teams that makes on the table here their different viewpoints on the problem. We have the captain of the academia team, that is Antonio Iara. We have Antonio Manzalini, that is the captain of telco operators. Antonio Iara is from University of Applied Sciences, Western Switzerland. Antonio Manzalini is from Telecom Italia. We have Konstantinos Kalabukas, that is the captain of Solution Integrators, and then Wolf Detman. I am sorry, but I have not indicated the other name. It is Antonio Escobar, but you will find these slides on the website, and I correct, of course, this. Okay, then we have Angelos Anadiotis, that from CNIT. CNIT is a consortium of telecommunication in Italy, of telecommunication universities in Italy, and it plays the role of the barrister. Barrister, this is the definition of Wikipedia, is a particular kind of lawyer that stays on the bar in the courtroom. And finally,
I would buy the drinks.
it's the white hairs. And finally, I am Giovanni Schembra, that I will play the role of moderator of this session. We organized this session as a play, as a game, with 4 different teams, the above teams, and we now invite you to register and to join these teams. We have organized 3 different channels, social channels. You can use you can register to the forum that is available on that website that is accessible through the also to the QR code, and you have the QR code also in the paper, in the document that Angelos gave you. You can tweet to iOS text, or easily you can email to iotstacks@gmail.com. These channels will be used now to start some discussion at the end of this session, but we can continue to use these channels after this session, because the target of this session is to make networking. So the idea is to have 4 different teams, one for each captain, and the discussion can continue after this session. I hope to see many comments and to see many discussion on these matters. In the first round, the captains have 6 minutes to introduce the problem from their perspective and to propose some solution they see available. Then, in the second round, during the first round, you can register to this social channel and to propose some question. The barrister, Angelos, is connected to the 3 channels in parallel and, and can observe your comments, so he will invite you according to what you have written on the channels, will invite you to explain more in depth your comments or your questions. Of course, the classical question of raise my hand and I have a question for this speaker, of course, is already valid. Finally, in the third and final round, the captains will sustain the speakers of their teams and answer some of the questions received by the audience. If we have many questions for problems of time, they can continue to answer to the questions through the channels that will remain available after the session. Okay, now we can start. I invite the first speaker, it is Antonio Iara, to propose, yes, his report. No, the slides. Can we invert with Antonio Manzanini? So we put on slides in here. No. Okay, you can start.
Good afternoon. My name is Antonio Angelini from Telecom Italia, from the Strategy Innovation Department, from the Future Center. The Future Center, we have the goal of looking a little bit into the future, thinking about the future rapidly. Micro, please. Oh, sorry. So we have the freedom to think a little bit out of the box of the establishment of the operator. So I'm going to present you my personal opinion on a way, on a vision which we have as a strategy and innovation future center to stop this war. We don't want to have any further war. We want to build alliances. We want to pursue a blue ocean strategy which is going beyond current competition and opening new ways of cooperating. This vision is very much based upon the development of an operating system, which is not new as an idea, because also we're familiar with SDN and VOO, the cloud, the edge computing already. This concept of operating system are well familiar, are well debated, even inside the big operators. But what we are presenting here is an operating system which should be pervasive and hyper-connected, so capable of paying the fil rouge from the terminals, from the smart things, up to the cloud, the edge, cutting across the network. This is a picture which I'd like always, well, not always, often show in my presentation, which is this cognitive toy. You know, it's a nice example because this contains all the ingredients we believe about the future evolution of the telco and ICT. We have this cognitive toy, which is a small dinosaur with the button on the bell, which is connected directly to IBM supercomputing center, Watson, through the network. And the story is this: the kid pushed the button on the belt of the dinosaur, makes a question, and the IBM Watson supercomputing responds to the question within a second. And also the supercomputer is getting to know the user and sort of tailor the contents. So it's a nice example of what we have today, but it gives you in a nutshell what might be the future. So in the future we'll have more and more of these things, smart things, toys, but think about also robot, autonomous machine, combination of sensor, actuators, whatever else connected. Via the network, we should be ultra low bandwidth, ultra low latency, ultra high bandwidth, to the enormous power which we have in the cloud and or at the edge. And this is an example of an overall trend which is dramatically changing the business of several industries, not only the telecommunication ICT industries, but several sectors, several ecosystems will change. Basically driven by a number of factors, which are the pervasivity of ultra broadband, fixed and mobile, the performances of the IT, and the downstream costs, which is as well important, the availability of open source software, virtualization, and more powerful terminal. This will create terrible complexity in the network, which is not only complication, but complexity in the sense of the complex adaptive system. So we have to find a solution. And well, one way, one vision which we are pursuing, which is already being, let me say, taken by some industries in the US, but also in Asia, is finding the right abstraction for the concept of service. If you're able to find the right abstraction of the concept of service, we can build somehow an integration, a fil rouge, across the three domains I mentioned previously, from the terminals, the edge, the fog computing, the network, and the cloud. I will not enter into the details of this, here we can discuss offline, but it's possible to come to service unification with an abstraction cutting across, the resources, the infrastructure, the service level, and it's very much based on something that we have already today in the standards. So, having said that, we can imagine this concept of service as a chain of service components, which are obviously have to have distributed across the infrastructure. By infrastructure, I mean in the large, from the terminals, things, up to the to the cloud. And the service per se will become a sort of unit of orchestration, so that the intelligence, the overall system will be the orchestration capabilities. But this is indeed something which is blurring the border between the cloud and the network on one side, and between the network and the edge on the other side. As telecom operators in the past, we are used to think about having the network and something which is attached to the network. We should forget this vision and considering something attached to the network as part of the network and also part of the cloud altogether. And for which this dream, which will change probably in a dramatic way, a positive way, several industries and ecosystem, we argue we need a sort of operating system. Allow me to take the metaphor, is simply the extension of the concept of the operating system which we have in our laptop, but in the network and in the terminals and in the cloud. So imagine the operating system having becoming a sort of nervous system of the telecom ICT infrastructure, having its own termination directly in the smallest device we have in our environment. And this is, well, the platform which should be developed in open source, and there are already trials. For example, I guess you know XOS, which is an initiative being developed by one lab with AT&T in the US. There are proposal ideas of building this operating system combining OpenStack with ONOS or with one OpenLife. So there are different alternatives, but the pieces of open source software on the table are already available to build it. And on top of this operating system that you may have, or the platform you wish to have it. But this is a sort of, let me say, fil rouge, glue, capable of integrating everything and allowing to exploit the concept of X as a service. This is what I want to put on the table for building this alliance.
Okay, thank you. Thank you. Okay, so from academia, oops, you have to start the presentation. Okay, let's go. Okay. Okay, so my perspective as academia, coming from the University of Applied Science in Western Switzerland, is very networking oriented. Right now the ecosystem that we find is that the Internet of Things is reaching everywhere. We have from the cellular approach, the telecommunication providers, but we have also the emergence of the smart cities, of the connected car, also residential, smart metering. So we have clearly two kind of needs, two kind of network, much more like capillary networks, focused on addressing the needs of the user. Another much more extended approach like the cellular approach, trying to provide global coverage. Of course, both of them, capillary and cellular, has totally different approach. From the capillary point of view, we don't have too much requirement regarding bandwidth usually because we are just addressing a small amount of data. However, we also look for this very small cost and really very reliable technology that could gather and collect all the data that we will have on that side. So this is going to be much more cost regarding repeaters and local infrastructure like mesh network, etc. Much more really than a cost about maintaining after the infrastructure. In the other side, we have the cellular approach. Don't worry, you will not invest in infrastructure. The operator will invest in infrastructure, but you will have an operational cost continuously to operate. As previously presented, they are much more like, okay, we will offer you a platform, a management solution, and everything as a service, and you will not really worry about connectivity. We will take care of all that part for you. Whoever in the capillary approach is very different. Usually, the end-to-end was much more like cellular, and IoT was much more like capillary. However, now the trends, in order to reduce this war, is about how to make all of them converge together. And there is where first we can see the kind of ecosystem where we have a lot of different standardization bodies, majority of them working in the capillary network, and also some of them working in the cellular network. We can remember, for example, OMA, Open Mobile Alliance, that working much more in the cellular, One-to-One working much more in the cellular area, and other like broadband technologies and also working in the cellular. However, some of the LAN technologies working in capillary network and some abstraction technologies that are mixed between capillary and cellular network. Here, the great advantage was now with One-to-One, that even when One-to-One was very focused on cellular, they started to think about, okay, we are cellular, but we need to take into account this edge network and this integrated into the cellular, into the common ecosystem. If we think about, it's not so crazy idea because both cellular and capillary networks share the same fundament. We are all now providing IP connectivity. We can talk about cis-loop-PAN for capillary or full IoT for cellular, but at the end of the day, capillary is IP connectivity. We are talking about everything as a service, can be RESTful, HTTP, or any kind of SOA architecture, but then, for example, in capillary we have constrained application protocol, but at the same time it's always everything as a service. And when we are talking about semantics and interoperability, one of the main promoters is OPA, that was Open Mobile Alliance, mainly working for cellular, but at the same time OMA did the lightweight end-to-end, working for capillary, so they are already again converging. And if we go to some semantics like W3C, like SSNXG, it's totally, let's say, irrelevant to say capillary or cellular. For them, all is data points, so they don't really worry. If we go this evolution, then we realize like, okay, one end-to-end is starting to build this connection point between cellular and capillary network, being totally aware with ETSI, because one end-to-end is based on ETSI end-to-end protocol, and ETSI end-to-end architecture is totally aware about IEEE, is totally aware about IETF technologies. So at the end of the day, it's really taking into account all what is going on and integrating into a common solution. In particular, about talking in this particular session that is about data management, OMA is specifically focused on device management and data management, providing you all the advantages about how to interface a sensor, how to register, discovering, maintaining, how to do some typical maintenance tasks like firmware upgrade, how to do the proper register and recovery of a sensor. So it's quite coherent. And again, the most important is that those protocols are supported from 2000 already in the telecommunication providers, in the cellular. Now with the lightweight end-to-end device management are also supported for capillary, and both of them are evolution, so are not compatible between them, but the platforms that support OMA DM for device management now are also supported lightweight, so it's a convergence point. And that is not also the most important. The most important is that OMA, the lightweight end-to-end, and OMA device management is the basis for one end-to-end. One end-to-end for the device management directly integrate OMA lightweight. They don't embed a new protocol. They directly put this into the stack. So we can see it's totally coherent. UDP, SMS for cellular, all the security into account, abstracted to RESTful, could be COA or any other RESTful. We have all the resource for the semantic, and most important, they provide us all the interface in order to make sure that from our cloud or any internet-enabled platform, do the proper interfacing for bootstrapping, configuring security, have all the information reporting for request data, subscribe to data, etc., etc. So you have all the interfaces taking into account security, and the most important, taking into account management. There is also some more details. Also, some alliances very focused, like Ipso Alliance, and now indeed also involving with the one end-to-end, providing all the semantic interoperability. And this is the thing, the most important picture. And then is a very clear map and evolution between what was IDF, talking about pure technology point of view, what is a client, what is a backend, what is a router, what is a server. OMA, that is already from 2000, speaking about device management and developing application for communication and telecommunication providers, defining also what is the architecture between application and server and client, and now with the coming one end-to-end, how everything integrated into the telecommunication provider into a coherent way being totally leveraged all the benefits for OMA and IETF protocols and architecture. So from my point of view, one-end-to-end is a kind of winner approach because it's taking into account all the best technologies already out of the market, already consolidated, and also at the same time not pushing one specific technology, also trying to open and offer alternatives between what could be required in capillary and could be required in Schembra and could be required for different integration. So for me, the common user stuff is that we have IoT in the bottom level with everything to internet, mainly IPv6 technology. After the web of things with everything towards co-op, HTTP, what we are talking everything as a service. Then the semantic web of things where we require much more semantic description with cellular, like one-end-to-end, capillary, like Ipsualian supporting really to the one-end-to-end, and now emerging standardization bodies. And finally, the application to really exploit all this data. So just to conclude, the vision is we started with the Internet of Things, connecting everything to Internet. Now with the Web of Things, we extend everything with everything as accessory capabilities. Now with one-end-to-end and the current approaches, we are trying to build ecosystem, making interoperable different heterogeneous resources. And now that we have a common definition is where we are really getting the big explosion with the global interoperability and capacity to integrate everything all together. And this is my approach, and let's speak. Okay. You have questions or whatever, just send an email, message, Twitter, and don't remember, academia is with. Okay.
Presentation. I have to answer. Excuse me, we can change this. We solve the problem.
Hello, my name is Kostka from Secure Logic. I'm going to talk about the software and the services point of view. So basically, we all understand the concept that because the services are the one that the user has seen experience, so we know the problem of the Internet of Things, this clustering and these silo platforms. So just to give you an idea of what we are doing, what is the status in terms of services in the market. According to IDC report, there is a different level of maturities in the functionalities for the enterprise, for the users, or for everyone. And we have smart homes, smart energy, health, and manufacturing that have the most important, the most maturity level compared to other things. Now, what that means that if we talk about there is this issue of cross-IT, cross-domain or cross-platform interoperability issues for us. That means we cannot see some things isolated. For example, we cannot see manufacturing as such because they are affected also by logistic processes. And they have both different domains, different concepts, notions, knowledges that have to be integrated. And of course, those are supported by billions of devices, as was said before. Also, there is this smart grid. There is this tendency to trend to integrate everything. That is smart home, electric vehicles, DSOs, renewable energy source. Everybody again might be supported by the different platforms, even from the same domain, or we have different domains. Also, mobility. We talk about intermobility, information sharing on events, and so on. And food supply chain, starting from agriculture, where you need to have this tracking and the conditions under which the product is being processed. So we can talk about on hours about those terms. I just want to give the importance why why from service point of view this is still a problem. Now I should have talked after Antonio's presentation, because Antonio made this very nice presentation of this operating system. So the idea is that we are not experts on this. The idea is that we are on top of this this attempt, this holistic approach that starts from sensors, and we have this visualization layer, this distributed operating system, and we do some kind of a service orchestrator, protocol translator, where we can take those abstractions from devices and services and try to make it a more homogeneous way and provide this services orchestration integration. From us, there are two types of challenges. The technological challenge that, for me, can be done. Technology always can be dealt with. So the idea is that from the existing status, where we have some abstraction, whether we can make this unified abstracted use of physical objects in order to make them more easily accessible and managed. And whether those physical objects can be uniquely enriched with information about their social relations, so to which each object or device is interacting with and under which conditions. So to have this knowledge, a total holistic knowledge of per device and per object. And second is, there are several IoT ontologies have been developed, targeted at different sectors. As we see, there is these different platforms, even in different domains. So how can we make one unified ontological model that can cater all this? This is the problem we face in many years in all these interoperability issues. Some ideas that can be as a food for thought is that we have this distributed enterprise service bus. The enterprise service bus is not something new. It's used in many years in this interoperability domain. So first we have to think about this ontological model that has to be supported to support this unified access to services and information. Then we should have this message-oriented middleware that can rely on existing DSP. We don't have to start from scratch, and can provide both asynchronous and point-to-point message exchange among the different components. And we have this unified ontology-driven access to data regarding the source and format. And to support also this, we can leverage the existing mapping technologies that can support the mapping and translation of the existing information of this technology. And the last thing is that from technology point of view, we have this service visualization. As Antonio said before, we have these abstractions and visualizations. So we can have these representations, virtual representation of services that can be easily understood and managed in a more efficient way in terms of which device I'm going to use in order to cater a specific task. This is the technology point of view, which I think the level of maturity is good enough to support this implementation. But there are other things that have to be also considered seriously. First of all, we talk about business process interoperability. It's not only technology, it's about how you align also your processes. Because we will talk about manufacturing logistics, we know the case that it's not only just how the sensors communicate each other, but as we see in a holistic way how this can support a whole flow that consists of different tasks from different domains. Second is the level of trust. I was talking to a new startup company. They want to do some energy solution, and they wanted to build their own sensor device, and said why? There are many. And the answer was no. If we buy someone from X provider, then this X provider might come later and sell services, and then they will kick us out. So it's still this reluctance of how you can open your solutions and to be more collaborative. And third is about this governance maintenance issue. When we talk about common ontological models, when we talk about something unified, it has to be supported from all partners. And this is also another issue that is being discussed many years in the interoperability. So this is from the application point of view. Thank you very much.
Yes, Costas. Okay.
So welcome. We are too. For Captain, it's always good to have an engineer to do the things later on and to realize them. So let's start. As a device manufacturer, we see a beautiful future before us. Everyone says there are a lot of 50 billion sensors in 2020. Yeah, they have to be supplied and they have to communicate, as we learned. You have to integrate them in the holistic framework and to do your applications with them. The point for us where we can have them, yeah, we have to have a right solution which fits into this game, and we cannot wait for standards. We have to fit already today. We can maybe move towards standards in the future, but we have to apply there. And the point where we have influence in our own devices and where we have to be prepared is in the software, in the communication stacks, and to enable security, which is a must for industrialization for some critical applications, and there will be a lot as well in our privacy life. When the microcontroller capability has to be given to get all the things and to have the operating systems which can cope with all the network operating systems in the whole context or orchestration as was done before. And how this will be or might be done, my engineer, Antonio will explain.
Hello. I want to give you a clear example of how this IoT problem of fragmentation prevents us to develop our IoT solution. We have a nice product, it's called XNC microcontroller. It's an ARM Cortex N3 MCU, low energy consumption and all this. So in theory it's a nice candidate for IoT, but in practice we are not really a competitor in this field. Anybody uses our microcontroller. There are several reasons. The main reason is that we are a German company, so we move slow, but I shouldn't say. So I will say that the reason really is that there is a wireless fragmentation, and this makes that we don't really use we don't provide a wireless solution in our microcontroller. If we see the main solution used nowadays in terms of wireless communication are 6LoWPAN, Bluetooth Low Energy, and Wi-Fi. They are other, but this is alright. ZigBee is also like 6LoWPAN at the lower level, so it can be a good example. If we see them, we see, for example, Wi-Fi has a nice IPv6 support, also 6LoWPAN, but Wi-Fi has a really high power consumption, so we cannot use for our IoT nodes normally. 6LoWPAN needs another gateway, which is quite annoying, and also it's expensive to have another gateway apart from your home router. And Bluetooth Low Energy, for example, doesn't support natively IPv6 or mesh networking. So at the end, that's one of the reasons why we don't jump over the IoT market, because we don't know which wireless protocol we should include in our microcontrollers, and we are really afraid because of this. There are some workarounds like the multi-protocol home router for Google, the Google On Hub, which support everything. There are also a perspective for a new Wi-Fi protocol in the future to address the low power market. Also, TI has launched a multi-standard wireless microcontroller unit with support a lot of protocols, but we shouldn't use anything from TI, so this is not a solution. But well, is this really a great problem? Is this the great problem of the 21st century in terms of technology? From my point of view, no. If you are only a solution provider, just use whatever standard that fits your needs. There are a lot, so just use one and launch your product and don't worry. And if you have selected a wrong one, then update your product, maintain some legacy support, whatever, but don't make this prevent you from releasing your solution, because standards are really a business and there will not be the holy grail of a standard in the future that will solve every use case, past and future. So, for me, and I must say this because I'm the security expert, the real problem in terms of standardization is security. Because in security you really need a standard mechanism, you really need a well-known and proven way of doing the things. And this is what we don't have now. And I think this is the main topic now, preventing the real explosion of industrial internet, or how the European Commission likes to say, Industry 4.0 or 4.0 or whatever. And I think this is the main topic, and if you join my team, we can discuss about this later, or via Twitter or whatever. Thank you.
So far from Twitter, we have from Manolis Nikiforakis. Okay, do you want to make your question?
Which one?
Both.
So I've been spamming the Twitter channel all this time. I'm gonna ask a different question other than what I have posted on Infineon on the last comment. So how are you going to solve the security problem?
I knew this question were arriving. From my point of view, we are talking about Internet of Things, so I will use Internet standard. This means you have a device, just support well-known and well-proven standard like TLS and DTLS, so use transport layer security. This is not the most efficient in terms of power consumption and code size and all this, but it's the best we have now. So I now use transport layer security, and in the future I've seen a lot of trends of using what is known as zero-knowledge cryptography and a lot of new fields, but they are starting now. So at the moment, if I have to provide a solution, I will use TLS.
Do you think over-the-air updates, OTA is important in your approach?
Yeah, I think this is a must-to-have in any IoT solution. Over-the-air updates, they must exist because of this standard work, because if you release your product with one standard and then your cloud provider shifts to another standard, you must have a mechanism to change and shift to another, and also for sure your product will have bugs and security holes. Yeah, it's really important.
I would like to answer you also a question. First one is that I am partially agreeing with him about security. I think that using DTLS is already a de facto issue. You use web service, if TLS or DTLS is there. The big challenge is commissioning. How you deploy keys and security and you maintain all the credentials, the key credentials in 50 billion of devices. That is the real challenge. How to commission all these devices. And there is when is a lot of pending too, about commissioning and provisioning of keys and certificates to everything. And there is a lot of emerging standards, but what is the winner, we will not sure. And about the second point, following I am totally agree about the commissioning, about the management, and over there, maintenance. And in fact, Open Mobile Alliance standard is mainly focused on device management. So the cool point from 1 and 2 is that from the beginning, they integrate the most powerful and most reliable solution in the market for device management. That at the beginning, the first standard that they released was about how to do firmware upgrade over there.
If you want to continue to Twitter, because we have also a question from...
I have 2 comments. First, I was sorry, Antonio, for very copying your I was quite surprised seeing from Telecom Italia the presentation I was expecting from an academia point of view, while I saw the Antonio presentation, typical presentation from a telecom director. So, I was expecting a longer term vision from the academia, not from the telecom director.
The truth is that
This is good
We
because
have influenced the operators.
it's good because it means that Telecom Italia, I'm from Italy, so seeing that Telecom Italia is finally moving from the old telco approach is a good thing. The second comment is related to security. Please don't make security just things that has to protect the communication, because TLS to TLS, it's focusing on protecting the exchange of data. Security means also identification, means access control, means what Antonio was saying, deploying identity and so on, which are still open issues, especially in IoT, in which the scalability is the for all aspects, including security.
Yeah, this is one of the main fields. I think it's also secure routing, and these firmware updates that you have said, they must be also secure. So it's not only the communication that is most of the, or that's already internet, HTTPS and all this, but it's all new field of challenges on scalability of field management, and all this is not yet well standardized. This is where the gap is at the moment.
Final comment that is related to which is step further evolution of Telecom Italia is to have a more advanced view which we have to start supporting the distributed in IoT. Even because in the US they are already moving in this area, and we have the risk to acquire, still continue to acquire solutions from the US.
I didn't mention it too much. The lack of time is part of our vision. We are talking about orchestration and whatever is behind that. Within the intelligence, distributed computing storage, which means they ready to evolve centralized stuff to the edge of the edge, and those data are there. So that's absolutely important. Again, one US and Asia are by far US.
Okay, thank you. I want to thank very much the speakers, the captains of the team, and I ask to the audience to continue to visit the channels and to support the captains of the teams, because they really need your support, and they are happy to answer any other questions. Thank you very much. Bye.